Hi, my name is Sri Chandra, and today my topic is relay selection based on Bayesian decision theory in cooperative wireless networks. Let's get into our topic. Relay selection is an important technique in relay-aided networks and has been extensively studied in the past decades. Conventionally, relay selection relies on maximization algorithms and accurate channel state information (CSI). When other issues coexist with relay selection, such as multi-hop relay and sub-channel allocation. The cost and resource consumption cannot be neglected. The bottleneck of optimization-driven selection and the delay development of machine learning inspire us to explore new selection methods, system model, and optimization-driven relay selections. Consider a dual-hop network with a source node, a destination node, and k node and forward. Relay nodes denoted by R1, R2, so on Rk. Converse extension scenario is assumed and direct link does not exist. For the convenience of analysis, we consider cluster relay scenario where the relays are located in a cluster and wireless channels of relays and independent are identical distributed trailing fade. HK1 and HK2 are complex channels coefficients from the source to RK and from RK to the destination. For DF protocol, the equivalent channel gain from the source to the destination via RK is expressed by GK. Min of GK1, comma GK2. GK1 equal to HK, comma 1 mod square. GK2 equal to HK, comma 2 mod square. And followed exponential distribution and with parameter lambda. Thus, GK follows exponential distribution with parameter lambda 2 lambda. System model and optimization driven relay selection. Conventional relay selection in dual hop transmission is centralized and optimization driven. A central controller collects GK1 and GK2 of all relays and selects the relay maximization end-to-end rate RK by solving the optimization problem expressed as k equal to arguments 1 less than or equal to k less than or equal to k, RK equal to arguments 1 less than or equal to k, k less than or equal to k, 1 by 2 log of 1 plus pgk by lambda sigma square equal to arguments 1 less than or k, k less than or k, gk. Here, sigma square denotes the variance of complex zero mean Gaussian noise, and P denotes transmit power of the two hops. To evaluate the performance of different relay selection schemes, average end-to-end rate is computed as a metric which is given by R bar equal to limit extends to t in limit t extends to infinity 1 by t summation t base t equal to 1 rk of 2t. Decision tree based relay selection. We consider supervised machine learning from solving relay selection problems. To be specific, we model relay selection problems as a k-class classification problem. Construct a classification tree for training data and predict the class labeled the current CSA belongs to. The decision tree based selection consists of three phases: preparing training data, building selection decision tree, and predicting relay selection. The system model and proposed scheme are briefly illustrated in figure 1. In the remaining part, we elaborate each phase of the scheme. Here is the figure 1 system model of the decision tree based relay selection. Preparing training data. Training data used by the decision tree based relay selection is denoted by G of x1, y1, x2, y2, so on xm, ym. Xm, ym is the mth sample consisting of input xm and output ym. Ym represents the selection result of optimal policy and is computed from using xm. Xm is the input vector containing k features. F equal to f1, f2, so on fk, and is given by xm equal to x power 1 base m, x square base m, so on x power k base m, where x power k base m denotes the value of fk. Generally, the input of a learning system is continuously CSA of the wireless network 1, 2. The input data required by the decision tree is a set of discrete values describing the object to be classified. We propose a feature extracting method which generates discrete features from GK1 and GK2, k equal to 1, so on k. X power k base m is generated. X power k base m equal to 1, 1 comma gk greater than 0, 0, gk less than 0, where 0 is a predetermined CSI threshold. This method is a binary quantization to gk, and thus xkm takes value of 0, 1. When preparing trading data, central controllers demands accurate value of GK1 and GK2 so as to calculate the optimal selection result and generate YM. They are also substituted into 4 to generate XM, and M sample contains both input and output are packed to form training data G. This process is conducted offline before the transmission are started. Building decision tree. The building phase is a recursive procedure of selecting the best feature with highest splitting terrain and splitting current data set by feature value testing. The procedure is repeated on each branch until one of the stopping criteria is satisfied. Splitting criterion is the metric evaluation, the impurity of a data set with regards to a particular feature. Most frequently used splitting criteria includes information gain ratio and Ginin index. Stopping criterion is defined. The splitting criterion is lower than a threshold, or the number of sample is smaller than a threshold, or for F is empty. In the proposed scheme, we use existing decision tree algorithms such as ID3, C4.5 or carrot. Classification and regression tree. Decision tree building is part of the initialization of the proposed scheme. The decision tree can be used in each prediction without any renewal as long as the network topology stays stable. Predicting relay scheme. In predicting phase, the central controller only needs quantization. Results of GK1 and GK2 to generate input data and accurate CSI is not necessary. Let G power Q base K, 1 and G power Q base K, 2 denotes the quantization results of GK1 and GK2 using the same parameters as feature extraction. The values of G power Q base K, 1 and G power Q base K, 2 are taken from 0, 1. So transmitting each of them requires only 1 bit. Then XM is generated by X power K base M equal to min of G power Q base K, 1, G power Q base K, 2. 1 less than or equal to K less than or equal to K. Conclusion. In this paper, we proposed a decision tree based scheme for dual hop wireless network. We designed a future extraction method which generates discrete features by binary quantization of each relay. Equivalent CSI. Two splitting criteria, information gain and Ginin index, were derived and maximized to optimize quantization threshold. Simulation results verified the optimization of quantity threshold and shown that the decision tree based relay selection schemes can achieve average end-to-end rate comparable to optimal selection. The advantages of the decision tree based relay selection lie is lower computational complexity, smaller feedback amount, and quantized CSI required. Future works may involve decision tree based relay selection with other relay protocols or INID relay channels. Here is my presentation. Thank you.